Algorithm evaluations can be found at algorithmia.com/valuations. They allow you to compare two or more different algorithms or versions of the same algorithm with each other to see how they perform, whether that's in terms of speed or other characteristics. Begin by pressing the Create Evaluation button, and then picking a name and optionally adding a description to tell people what it's going to be used for. Decide whether you'll be creating it under your own account, or if you're a member of an organization, you can place it under that org. Lastly, you can make it either public, so everyone can see it, or private, so only you have access. Next, we'll add as many algorithms as we like to this evaluation. We do that by hitting Add Algorithm, then either locating it in our own list of algos, or pasting in the identifier of that algorithm. When you hit the arrow, you'll then be asked to choose which version of that algorithm you want to evaluate. Repeat this process for as many different algorithms as you wish to compare, whether they be ones that you yourself have added or others that are publicly available anywhere inside the catalog of algorithms. Next, we'll start thinking about what sort of data we're going to pass into these algorithms in order to evaluate. Here's one example. Note two elements here: the iterations value, which tells me how many times I'm going to run my algorithms, and the payload value, which tell me what actual input I'm going to pass into each of those algorithms. Now that I know what I want my input to look like, I'll go about creating an evaluator algorithm, something that takes the input and passes it to each of my algorithms in turn. I'll hit the Add Algorithm plus in the upper right corner, pick whether I'm going to create this under my own account or my organization, and give it a name. I choose whether to make it open source or closed source, and I'm going to give it access to the internet in case I want it to pull any data from the web, and allow it to call other algorithms as well, because of course it needs to call the algorithms that I'm going to be evaluating. I'm going to copy in some code I wrote earlier, and let's walk through it to see what an evaluator algorithm should look like. First up, I'm just going to import Algorithmia as per usual, and also the algorithm exception package, just so I can send back some nice errors if anything goes wrong. I'm also going to import time so that I can time what I'm actually doing here and give back information about how long it took to run each part of the algorithm. Create an Algorithmia client as per usual, and then let's start here at our usual entry point where I would normally be stepping into my function. So the first thing I'm going to note is that I need to evaluate a particular algorithm on each run. So what's going to happen is when I actually do this execution of my different algorithms that I want to evaluate, it's going to call my evaluator algorithm multiple times. And each time it's going to pass in the evaluated algorithm parameter to tell me which algorithm I'm actually running this on at a time. So I'm going to check for that evaluated algorithm value on the input. And if it's there, I'm just going to assign it to a local variable. If not, I'm going to raise an algorithm exception here to let the user know they should have passed me one in. I'm also going to accept a parameter iterations. Now, this is not something that's defined by the spec. This is just something that I want to be able to pass in each time so that I can actually run this in a loop inside here so that I can get more tests per run. And that's just going to make it easier for me to evaluate this otherwise fairly short running function. Now, if I was doing something that was not itself a naturally short execution time, so maybe not running like a small natural language processing model, but running a relatively large, say, object detection model, then I wouldn't necessarily need to iterate inside my evaluator itself because each execution itself would run a fairly large amount of time, for a fairly large amount of time. Next, I'm going to customize my input depending on which algorithm I'm going to be executing it on. So different algorithms that I might be running from this evaluation might require slightly different input formats. And here's one example. If I detect that the person's calling web HTML data extractor, I'm going to add the XPath parameter to that input payload that I'm going to be sending on to that algorithm. Otherwise, I know my other algorithm, Scrapey, that I'm evaluating doesn't need to be altered, so I'm just going to leave the payload untouched as it was passed in. And that keyword payload, that's not something that, again, is defined by the spec. That's just something that I've decided is going to be the parameter I send in that's going to contain the data I want to actually evaluate each algorithm against. You could use any argument name you wanted there. The only thing defined by the spec is this evaluated algorithm parameter. Now that I've got all that information, I'm going to go ahead and execute a batch on each algorithm for a specific number of iterations, and that's defined down in my execute batch function here, which I've broken out just for simplicity. So execute batch takes a number of iterations that I'm going to run on, an algorithm I'm going to run it against, and the payload that was passed in by the user. I simply iterate over the number of iterations I'm going to need, and here I am timing each actual execution. So I simply set a start time parameter as the current time in milliseconds. I go ahead and run the algorithm I'm going to need via the usual client.algo.pipe call, passing it that payload that was passed in to me. And then I figure out the total amount of time it executed for by just taking the current time in milliseconds again and subtracting the start time. Now there's a reported time given by the actual response, and that is result.metadata.duration, and that's the number of milliseconds that it actually took to execute, the amount of compute time that was used. So when I subtract my call time, what I observed from when I started that call to when it ended, and I subtract the actual compute time, that tells me the amount of loading time it took, the amount of overhead that was there when I called that algorithm. So I'm going to report back both of those. I'm going to append into an array the amount of loading time I calculated and the actual execution time that was reported. And by the way, just for convenience, I'll also report back the number of results I got. Now, in this case, I'm calling my scrapers on a specific number of domains, so this length of returned results should always equal the number of domains that was passed in, but in a more complex environment, you might have some other value you want to report back. I'm going to send back those three arrays to my calling function, and then I'm simply going to report them back, passing them out of the evaluator algorithm. Now, when the machinery runs this evaluator, it's not expecting any particular set of return results. You can just give it back a dictionary of any abstract set of keys and values you want, and it's going to put those into a tabular data set for you to look at afterwards. So I can simply choose on the fly what I want those to be. So I'm going to create one parameter called average load time, and that's just going to be the average of all of the loading times over that set of runs. And I can see down here I just have a very simple function for averaging out all those values and formatting the result. I'm going to pass back the average execution time of all of those runs. So this is the reported actual compute time for each function to run, and that num results value that I gave back. Once I'm pretty sure that that code is good, I go ahead and save it, and then I'm just going to do a really quick test run right here. And in this case, I'm passing in the number of iterations and the payload. Now if I go ahead and I just run it like that, it gives me that error right here that I actually created saying, hey, you forgot to specify which algorithm I'm actually running this against. So I'm going to add one more parameter to that input. And that's going to be which algorithm I want to run it on. Now this isn't something I'd normally be passing into the evaluations framework. It's just something I'm going to pass in on this one run so that I have something to test on. That done, let's try it again, running on a specific algorithm. Now it's going to take a little bit of time to churn away because if it's worse, it's running 5 iterations on each of those domains that I've specified there, and I get back some useful results. The average execution time in milliseconds, it looks like it was about 1.06 seconds of execution per call, and the average load time over all of them, less than a quarter of a second, and then the number of results, 24. That should match the number of actual domains that I passed in here, which was, yes, 24. Now that I've got that ready to go, I can hit publish, step through the publishing wizard as per usual. If I want, I could pass in some sample input here just so other people could see it. For now, I'm going to skip that. Publish this either publicly or privately. If you are running a public evaluation, it would be very useful to have the evaluator algorithm you're running actually be public so that people can go and they can look at it. And then once I've done that and published it out, I can copy the URI, the identifier of that evaluation, go back to my evaluation that I'm creating, and now down here at the bottom where it says evaluator algorithm, I click choose existing, punch in that one that I just made, and add that. And now what it will do is when I fire this off, it'll run my evaluation algorithm and pass in each algorithm that it's going to evaluate into that as the evaluated algorithm. But of course, I also need to give it the actual input I want it to run on each time. So here's my basic package of information I'm sending in. I'm going to have it run 5 iterations on each test, and I'm going to hand it all of these domains as the actual payload. I hit save input, and now we're ready to run. I've got my 2 algorithms set, I've got my evaluator algorithm set, and I've got my input set. Now I can go up and hit run evaluation. It's going to kick that off, and then I can head over to the results table and watch as it cranks through those. It's finished the first run on HTML data extractor. It's given me that total execution, that average execution time right there, and that average load time right there. We'll notice, by the way, that this is much, much lower than it was in my initial run, only 26 milliseconds, and that's because now the algorithm is warm and ready to run as many times as I need it to. The first time I tested it, it hadn't been run for a long time, so it was suffering cold start time. Down here, Scrapey demo, the other one that I was running, I can see that it's a little bit slower, in fact about twice as slow on the actual individual executions as the HTML data extractor. And so I know that probably I'm going to end up going with this one when I actually roll my application out into production. Similarly, I could have had 2 different versions of the same algorithm that I was running here, or I could be testing 2 different machine learning models head to head to see which one's going to perform better. I might be interested in execution time. That's what I care about right here. But keep in mind, I can always pass back num results or some other variable. So I might, for example, be doing an object categorization, an image categorization algorithm, and then I would pass back something like the accuracy or maybe the number of objects detected as my metric instead, because that's something I'm going to want to look at in my results table and care about. You can go back to algorithm evaluations at any time and create as many evaluations as you like. When you do that, they can be your own evaluations or they can be ones that are available across your entire organization. And again, they can be either public or private. I can see right here by this indicator that these are both private. But if I made a public one, then I could then send that link to anybody else who's on Algorithmia, and they could step in and they could run an evaluation on their own data and let me know how it worked. All right, thanks for watching. Go ahead and have fun with this.